Hello students, our next topic is alkaline earth metals. Nothing but what second A group of elements. Now let us see the physical properties of alkaline earth metals. Here, if you see here general electronic configuration, what we have here along with the noble gas configuration, outermost valence shell configuration, we have Ns2, isn't it? Okay. Let us see the elements what we have: beryllium, magnesium, calcium, strontium, barium and radium. Now these are the atomic number of particular element, and if you see the electronic configuration, as you know very well, along with the noble gas we have the outermost electronic configuration what we have Ns2. Okay, in this here we have the what radon. This is not the okay here radon. Radon is a what radioactive elements, means what it is going to emit alpha, beta and gamma rays. That type of elements called as a what radioactive elements. So in the first group what we have francium, isn't it? Now in this group radium is a what radioactive element. Now if you see the atomic radius and ionic radius, okay, the atomic and ionic radius of these elements are quite large but smaller than those of the corresponding alkali metals. Here, as you know very well, what we have in is black, as generally you know very well in a periodic table. Okay, if you left to right, if you go, what happens? Size is going to be decreases. So they have the atomic radius and ionic radius is more, but comparatively, okay, first A this second A elements, nothing but what alkaline earth metals having the somewhat smaller size. Why? Because means due to increased nuclear charge of these elements. As you know very well, nuclear charge is going to be increases. The atomic ion as well as ionic radii go on increasing down the group due to gradual addition of extra energy level. So what happened here? Here we have the element what we have beryllium, magnesium, calcium, strontium, barium and radium. Okay, so what happened here? If you come to top to bottom, as you know very well, the number of shells is going to be increases. So atomic ion, what happened? Ionic radius also going to be increases. Now here you can see the what atomic radius increasing order. Okay, here we have the ionic radius. These values you can see. Okay, we are taking the ion. So ionic radius also from what top to bottom in a group going to be increases. Next, if you see the density here, so these are much denser than alkali metal is because of the smaller size and greater nuclear charge and mass. Here what happens, if you see the density compared to first A group elements, okay, they have the more size. Why? Because means as you know density is more. Why? Because means left to right size is going to be decreases, isn't it? So because of so smaller size and they have the what the more density compared to alkali metal. However, here first it decreases from beryllium to calcium and then steadily increases from calcium to radon due to different types in the crystal structure. You can see that here beryllium to calcium, first there is a what here decrease, isn't it? Okay, the value you can see here, there is a decrease. After that there is a increase. So what is the reason means here? So if you see the crystal structure, depends on the crystal structure. As you know very well, for example, you can go further. For example, I have the 4 balls, isn't it? Okay, 4 balls you can pack in such a way. Okay, I'm talking about the atoms. Okay, nothing but balls means nothing but atoms. So what happen if you arrange here if 4 balls, like if you arrange very closely, what happen, the value is very less. Value is less means what density going to be increases. If you arrange like this, what happen, value is more means density going to be what happen here, value is more means density going to be decreases. So Mean depends on the crystal structure. Okay, so here you can see the order. Okay, here this is the radium, we have the more, then barium, strontium, beryllium, calcium and magnesium and calcium. This is the density order. Next, if you see melting point, boiling point, here they have the higher melting point, boiling point than those of the alkali metal. Remember first A group, because of what? They having the more number of bonding electrons. Why? Because means in the valency configuration what we have, ns2 means we have the 2 electrons. But in case of what happened, we first A group elements we have ns1, isn't it? So if you see melting point, boiling point decreases down the group with exception to magnesium. Generally what happened, top to bottom going to be decreases, but exception is what? Magnesium. Here you can see the values. Okay, so this is the melting point and boiling point values. Here if you see the order, decreasing order, here beryllium is more, then calcium, strontium, we have the least, we have the what? Magnesium. Next, if you see the metallic properties, okay, these are silvery white metals. As you know very well, alkali metals, alkaline earth metals, isn't it? We are talking about the S black elements, we have the metals. So here these are what? If you look like, they look like some silvery. Here you can see somewhat silvery, okay? Not all, so somewhat. Now, if you see the softness, they are soft in nature but harder than the alkali metals due to stronger metallic bond. Here already we discussed. Okay, in the first group, for example, sodium you can cut with the knife. Okay, but here these are also soft but not that much of our first A group elements. Okay, why? Because of strong metallic bond. So compared to alkali metal, here alkaline earth metal are the second A group elements having the strong metallic bond. Now here if you see ionization enthalpy, the first ionization enthalpy of alkaline earth metals are higher than those of the corresponding alkali metals due to smaller size and ns2 configuration. So here if you see the ionization enthalpy, as you know very well, in the periodic table what happened, left to right size is going to increases. So we have the here first A, this is second A. So what happens, size is less means ionization enthalpy more. So because of smaller size, and as you know very well, ns2 electrons are paired. So because of this reason they have higher ionization enthalpy. Here you can see the IP1, IP2. Why? Because IP2, how you are going to get IP2 means? IP1 means what? We have the for metal, if you remove one electron, that is called IP1. The energy required to remove the first electron. Next, if you remove the electron from this one, monopositive cation, that is called IP2. Now you are going to get the one M plus 2 ion. Why? Because in the valence shell we have the 2 electrons. Here you can see the order. Okay, beryllium, magnesium, calcium, strontium, radium and barium. Now electropositivity character, here is these are the strong electropositive element due to this large size and comparatively low ionization enthalpy. Here if you go further moving down the group, the electropositivity character increases due to increase in atomic radii and decrease in ionization enthalpy. As you know very well, from beryllium to magnesium, here what happened, radium, as you know very well, what happened, the atomic size is going to be increases. So once sizes increases means what? Ionization enthalpy going to be decreases. So they can easily leave the electron. So from beryllium to radium what happened? Electropositive nature going to be increases. Now if you see the oxidation state, as you know very well, they have the one general oxidation state as a what? Plus 2. Why? Because means in the valence electronic configuration what? ns2. Once they use the ns to 2 electron, they are going to get the noble gas configuration. So in the solid state, the dipositive ion M plus 2 forms strong lattice due to their smaller size and high charge. As you know very well, in the cation means M2 plus 2 we have the what? As you know very well, from the parent metal, this having the what? Small size. So in the ion size having the what? Strong lattice. Why? Because of smaller size and they have the high charge. You can see the charge, we have the plus 2. Now in aqueous solution, M plus 2 cations are strongly hydrated due to their small size and high charge. Okay, the hydration energy released by the M plus 2 cation is very high. So hydration enthalpy already we discussed what happened here. So this cation going to hydrate what? is going to attract the water molecule around it. Okay, so during that process some amount of energy going to liberated, that is called what? Hydration enthalpy. So here what happened, we have the +2 charge means small charge, so smaller size, so it's going to attract more water molecule. So because of that reason what happened, it's going to liberate the more energy. Nothing but hydration enthalpy is more. Okay, they are going to, it means here there is the more amount of energy, that is what hydration enthalpy is more. Next we have flame coloration. Okay, so alkali earth metals import a characteristic colors. Okay, what are the colors we can see here? So as we move down the group here, calcium to barium, the ionization enthalpy decreases, hence the energy or frequency of emitted light increases. Here what happens, if you see beryllium magnesium, before that what we have here, beryllium magnesium. Okay, because of their higher ionization energy do not import any characteristic color of the flame. So here what happened, beryllium magnesium having the high energy to remove the electron, Ns2 electron from the valency shell of beryllium magnesium, we need the high energy. Okay, that energy not sufficient with the flame, so they are not going to import, they are not giving any characteristic color with the flame. But now if you see here, as you know very well, calcium to what happened there, ionization enthalpy going to be decreases. Nothing but you can remove the electron easily with the flame. So here we have the calcium giving the brick red color. You can see here strontium is crimson red and barium is giving the what? Apple green color. Okay, here you can see the colors of the alkali earth metals. These colors you have to remember. In first group, lithium also giving the what? Crimson red color. Here hydration enthalpy here. So already we discussed, like alkali metal ions, the hydration enthalpy of alkaline earth metal decreases with increase in size down the group. Here why? Because means here beryllium +2, what here we have the ion beryllium +2, Mg +2 and calcium +2, strontium +2. So like that we have. Okay, so if you see the size of the ion, what happened from beryllium to strontium and barium, what happens, size is going to be increases, isn't it? Size is increases means what happened, it's going to attract less water molecule. Okay, so here what happened, beryllium going to attract more water molecule. Why? Because means having the small size, so more water molecule means what happens, going to liberate more energy, that is called hydration enthalpy. So beryllium giving the more hydration enthalpy. Now hydration enthalpies of alkaline earth metals are, ions are larger than those of alkali metals. Thus, the compounds of alkaline earth metals are more extensively hardened than those of alkali metals. So here what happened, for first group elements what we have only +1 charge. Okay, here what we have in the case of alkaline earth metal, we have the +2 charge. So more charge means going to attract more water molecule. So hydration enthalpy compared to alkali metal, alkaline earth metal, they have more. Here you can see the salt. For example, magnesium chloride, calcium chloride. Okay, they are going to exist what, 6 water molecule. Okay, hydrated means they are going to, in the crystal they have the 6 water molecule. While sodium chloride, what happened, they do not form any such hydrate, means they are not going to take the water molecule. This is a different. Okay, why? Because means they having the size of the cations less, they are going to attract more water molecules.